In this video, I'd like to go through a couple of examples on how we're going to calculate the molar mass. So calculating the molar mass of a compound. In a previous video, we worked through calculating the molar mass of one compound, H2O, and I want to go through the details of being able to calculate the molar mass of a compound. So let's say that we've got H2SO4, and we want to calculate the molar mass of H2SO4. The first thing that I do want to remind you of is when we're calculating the molar mass is just simply the mass of 1 mole. So the molar mass is the mass of 1 mole, and it's 1 mole of whatever you have. So 1 mole in this case of a compound, and the compound is H2SO4. So maybe if I were to draw an H2SO4, so let's put maybe the S in the middle, the 4 O's around it, and then 2 H's connected to 2 of those O's. What we're doing is we're going to be putting 1 mole of that substance on the balance. So that means if 1 mole, if I put a pair, that means I'd put 2 of them on. If I put a dozen, that means I'd put 12 of these on. But in this case, I'm putting a mole, which is 6.02 e to the 23rd, and H2SO4 is a molecule, so I'll call them molecules of H2SO4. So we're putting that many H2SO4 molecules on the balance, and I want to know what the balance is going to read. That's what this question is asking, the molar mass of a compound, calculating the mass of 1 mole. So if I put that many, 602 billion trillion molecules on that balance, what's the balance going to read? Well, here's how we do it. The first thing we do is we list out every single one of our elements that we're dealing with, and then we count them. There's 2 H's for each molecule. There's 1 S for each molecule, and there's 4 O's for each molecule. Then I'm going to go and multiply by their individual element's molar mass. So for hydrogen, I'm multiplying by 1.0. For sulfur, I'm multiplying by 32.1. I'm rounding to the nearest tenth. If you take another chemistry class, maybe they'll have you round to the nearest hundredth or the thousandths. This class, we're rounding to the nearest tenth. So we'll go 32.1. And then oxygen, 16.0. So it's just like going shopping and buying 2 H's, and they each cost $1. 1 S, and it costs $32.10. 4 O's, and they each cost $16. And so we're going to add all that up. 2.0, 32.1, and 64. When we add all that up, you get 0.1, and then 10, 9, 100.1. I'm going to check to make sure that I added that correctly, and I did not. This is really an 8. That's what I get for trying to go fast. 4, 2, and 2 give me an 8, and then that gives me a 9. So that's 98.1 grams. The way that I interpret this number that I just added up is the molar mass. Here's how we write it. We write 1 mole of H2SO4 is equivalent to 98.1 grams of H2SO4. So that means my scale will read 98.1 grams. So the way that we can think about this for counting by weighing, there's no way we're going to be able to count out 602 billion trillion molecules of H2SO4. But we can count them by weighing, and that's what a mole allows us to do. Count by weighing. And so what we do, instead of counting out that number of molecules, instead this is a liquid, we would be pouring on the liquid onto the balance until the balance reads 98.1 grams. Once we have 98.1 grams, we know we have a mole, because that's the molar mass from the periodic table, which is equivalent to that many molecules, 602 billion trillion molecules. So the molar mass allows us to count by weighing. We weigh out the substance to get it equivalent to its molar mass, and that will tell us we have 1 mole, which is 602 billion trillion. Just like 1 pair would equal 2, 1 dozen would equal 12, 1 mole is equal to that many molecules. I'd like to go through one more example with you, and let's look at this example, CaNO3 2. So if I want to calculate the molar mass of this substance, what I'm going to do, the idea, the concept behind the molar mass is I'm putting, now I think what I'll do is I'll just put a box around this. Actually, maybe I can write it. Ca with an N and 3 O's and another N with 3 O's. There's a Ca, that 2 gets distributed to the end, so 2 N's and then 3 O's on each. So I'm going to put this one thing on there. I want to put on 1 mole of that substance, which is the same thing as putting 602 e to the 23rd. Now, I can't call this an atom because it's more than 1 atom together. It's a compound, so the question is what kind of compound? Here was all non-metals, so we called them molecules. But here is a metal bonded with non-metals, so we have to call them formula units. It's just the way that it's bonded together. We're going to put that many formula units on this balance, and I want to know what the balance is going to read. So I'm going to list out each element. I list out Ca, I list out N's, and I list out O's. Now the N, there's 2 of them because that 2 gets distributed, and there's 6 O's because that 2 gets distributed to the 3, which gives it 6. And I'm going to multiply by its molar mass. So 40.1 for the calcium. Nitrogen would be 14.0. And oxygen would be 16.0. So 1, go shopping and you buy 1 calcium at 40.1. You buy 2 nitrogens at 28.0. So 2 of the oxygens would give you 32. So you triple that and you're going to get 96. 6 times 16 is 96. So that's 0.1. That's 14. Carry the 1. That gives you 11, 15, 164. If I added it correctly, I'm going to check because I'm not using a calculator. 0.1 of 14, 5, 6, 7. That gives you 164. The way you interpret this number once you add it all up, the way that you interpret this number is you say that 1 mole of CaNO3 is equivalent to 164.1 grams of CaNO3. This here is the molar mass. That's the calculation of the molar mass, the mass of a mole. And we interpret that based off the number, the atomic weight from the periodic table. So now that means the scale would read 164.1 grams. So what we do is we take the container of CaNO3, we start scooping it on the balance until the balance reads 164.1 grams. Once the balance reads 164.1 grams, then we know we have 1 mole, which means we have that many, 602 billion trillion formula units, 6.02 e to the 23rd formula units of that substance. We cannot count out that many formula units, 1, 2, 3, all the way up to 602 billion trillion. That's impossible. So instead of counting, we are counting by weighing, And the way we count by weighing is using the molar mass, the mass of 1 mole. When we measure out 164.1 grams of this substance, we know we have 1 mole, which means we have exactly 602 billion trillion formula units, 6.02 e to the 23rd formula units of calcium nitrate. I hope this helps with calculating the molar mass as well as the interpretation of the molar mass.